Good morning, everyone. Okay, so what we have discussed in our previous session was about the surplus and the slack variables. So let me just quickly give the uh, brief idea about both these things, and then we would be starting with our simplex method, the calculations of our simplex method. Now, this particular method requires utmost attention, so it is highly essential that you all please provide your attention for this particular lecture, because if you are not providing the attention for this particular lecture, then it will be difficult for you to understand the simplex method. Although the graphical method was very simple, but this simplex method is totally different than what its name suggests. That is the simple. It's not actually the simple. It's something complex, but easy method, but requires some attention in understanding. Okay. So we have seen that the slack or the surplus variable. Let me, okay, I guess I have shared the whiteboard screen. So I hope it is visible, right?
Yes, sir.
Okay, so we have seen the slack variables and surplus variable. So this both the variables we have seen by taking the example of the potatoes. So let's say if I am having one of the equation, this one and this one. Then in both these equations, what we used to do in our graphical method, we used to convert it into the same equation and then find the points. But we have seen that because of this inequality and conversion of the inequality to the equality, you might give us the change. This change is not, but it is quite not obvious change in the mathematical aspect. If you are saying that you are having x1 rupees which is less or equal to 250, then this x1 doesn't say that you are having 200 rupees or 210 rupees, 220 rupees or 180 rupees or 0 rupees. So that means if you are writing this particular statement, then it doesn't mean that you are having 0 or 180, 200, 220, even 250. So it's quite not sure. It is quite unsure type of the statement which we deal with using the inequality. So what we do, we use in this particular statement in order to balance both these sides. In order to balance both the sides, we use x1 plus x2. This is less part. This is left side and this is right side. The left side is less than the right side. So we use s1. And for the second one, x1 plus x2, this left side is greater than the right side. So in order to balance it, we use s2, for example, any variable s2 on the right side. Now, if I just iterate it, then I can write the same as S2 equal to 250. In this particular case, this is the variable that is being added in this left side. So it is called as the slack variable. This is a variable which has been subtracted. So you are removing some part. So it is called as the surplus variable. It is called as the surplus variable. So this is what we have already seen with its examples. Also, we have understood what we actually mean by these things. Okay. Now we would be directly moving into the discussion of the simplex method. And with the discussion of this particular method, I will be explaining you each term, what we are doing and how we are doing, and even why we are doing these things. So for this thing, you will be learning all these concepts of the simplex method by just looking into the examples that we are going to solve right now. Okay, so everybody just be with me and start noting down the things, whatever I am writing. I am first of all writing the question. Suppose our question is of the maximization. Maximize z is equals to, let's say, 12x1 plus 16x2, subject to constraints. The constraints are 10x1 plus 20x2 less or equal to 120. 8x1 plus 8x2 less or equal to 80, and x1, x2 greater or equal to 0. This is the non-negative constraint. Now, the first step, I would be writing over here step number 1. First step is to convert inequality to equality. This is our first step. So how we can convert inequality to equality? By adding the slack or the surplus variable. So our first constraint, now over here the inequalities are lying in the constraints only. So first of all, I will be writing the constraints. I will be writing the constraints. That is 10x1 plus 20x2 plus s1 is equals to 120. And another will be 8x1 plus 8x2 plus s2 equal to 8. This is what I have written the constraints, the same manner in which we used to have. So over here, I will be writing s1, s2 are slack variables. S1, S2 are slack variables. Now, can anybody say, open question to everyone, what will be the probable values of S1 and S2? What could be the probable values of S1 and S2? What could be the probable values for S1 and S2? Okay, let me just make it more simple. I have received one answer. So, okay, one answer that I am getting is negligible. Fine. Okay, to make it more simple, let me just have one highlight whether S1 will be negative, whether it will be positive, or whether it will be less or equal to 0, greater or equal to 0, or 0. What could be the property of S1? Positive, negative, less equal to 0, greater equal to 0, or 0. Right. Yet and Isha both have given the correct answer. Greater or equal to 0. Correct. Krishna also greater or equal to 0. Right. Fine. So I will be writing S1, S2 greater or equal to 0. Along with this, I will be mentioning X1 and X2 also because they are also non-negative. Now, if you just focus on the question that has been given over here, X1 and X2, they are our basic variables. Basic variables. Why I am calling them the basic variables? They are present in our objective function also and in our constraints also. So they are nothing but the prime variables or the basic variables. You can call it to be the prime variables or basic variables. Now, we have just molded our question with the slack variables. We have molded our questions by considering these slack variables. S1 is one slack variable, S2 is another slack variable. So that means we need to change our objective function also. Why we need to change our objective function? The reason is that over here we are having the slack variable S1, slack variable S2, but the reason is that in our objective function we are having only X1 and X2. So that means we need to change that thing also. So what I will be doing, I will be modifying the objective function to be Z is equals to 12x1 plus 16x2. Now, what is the purpose of modifying this thing? The only reason is that whatever variables are there in the constraint should also be included in the objective function. Because ultimately the constraints are nothing but it is because of the objective function. You want to either maximize it or minimize it. You want to maximize or minimize the values depending on the constraints that are enforced on the variables. Now, since you have added S1 and S2 in your constraints, you need to add it over here also objective function. But now, if you can just look over here, if you can compare both the objective functions, this was the original objective function, this is the modified objective function with the slack variables, then both will be different. Now the objective function can't be different, so what we will be doing, we would be having 0s1, 0s2. That means we are multiplying with 0. Now both are the same things. So this is the first step, that convert inequality to equality. How? By adding the slack or the surplus variables and change the objective function. How we can change the objective function? All the slack or the surplus variables will be appended with 0 or will be multiplied with 0 in the objective function. This is the first step. Step 2. Step 2. Create simplex table. Oh, I can't write. Right. Okay. Create simplex table. Now, how we can create the simplex table? So for that, let me first draw the table and then I will be explaining what we have done. These are all the notations which I will be explaining once I just write all the things over here. Okay, so this is the simplex table that we are going to fill up. Now, what does this mean? CBI, that is the coefficient of the basic variable. Coefficients of the basic variable that are in current equation. So I will be writing over here coefficient of basic variable in current iteration. This Cj is nothing but coefficient of basic variable. Again, the same thing, coefficient of basic variable. But over here, CBI, I stands for the iteration, in current iteration. And this is the coefficient of basic variable that is there in the objective function. In objective function. This is the solution, this is the ratio, and over here we have enlisted all the basic variables. Now these basic variables are nothing but now we are adding S1 and S2 in our objective function. So it will be nothing but x1, x2, s1, s2. They are all for the basic variables that we are having in present. Now over here, just fill the values of the coefficients of the basic variable in objective function. So what is the coefficient of x1 in objective function? It's 12. So right over here 12. What is the coefficient of x2 in our objective function? It's 16. So write 16. What is the coefficients of S1 and S2, the slack variables in the objective function? It's 0 and 0. So you simply consider the coefficients of the basic variable in the objective function. Now comes over here the table format. The number of rows that we'll be filling will be equal to the number of constraints. Let me write over here, number of rows in table will be equal to number of constraints. So how many constraints you are having? We are having 2 constraints. So we would be filling up 2 rows. How? 2 rows. So first row will be representing the first constraint and the second row will be representing the second constraint. So just fill up all the coefficients corresponding to the first constraint. So what is the first constraint? This one is the first constraint. 10x1 plus 20x2 plus s1 equal to 120. So in the column of x1, just write 10. In column of x2, just write 20. In column of s1, just write 1. Why? Because s1 is having the coefficient 1. In the first constraint only, there is the first constraint. And the coefficient of s2 is 0 because we are not having that coefficient, or we are not having that slack variable s2. The solution is nothing but our answer, so it's nothing but equal to 120. The second constraint is 8x1 plus 8x2 plus s2 equal to 80. So this is our second constraint. So just fill up over here the values 8801, 80. So what we have done, we have simply considered the coefficients of each constraints in each row. Now, the next step, whenever you will be creating the simplex table for the very first time, at that time over here, this particular column will be the variable in consideration. Will be the variables in consideration. Now, at the very first instance, for the first table, you will be considering the slack variables, always, slack or the surplus variables. That means always you will be calculating or considering whatever slack or the surplus variables you have considered in your objective function or constraints. So in your mathematical model, whatever slack or the surplus variables you have considered, you will be writing in this first column, or second column, you will be writing in the second column. And CBI, that is nothing but coefficient of basic variable in current iteration. So what is the coefficient of basic variables in the current iteration? So in the current iteration, S1 is the basic variable. So what's its coefficient is 0. In the objective function, it's 0. This is also 0. So right over here, 0 and 0. This is our table. Now, what to do with the table, I will be explaining now. But before that, anybody having any doubt in filling up this table? If you are having any doubt, then you need to ask now only, because the things will be going to have some complications at later stages. Is this formulation of the table easy and clear? I am getting 6 responses till now. Okay. Okay, so should I explain it again? Anyone? Is it required to explain it again? Okay, fine. So let me explain the entire table again. So this is our table that we will be filling up. Now with this reference of the table, what we have done, we have considered the basic variables. Okay, Devansh and Som, I will be coming back to your answers once I complete the explanation of this table again. Okay, so what we are doing over here, this is nothing but the table formulation that we would be required to have. So x1, x2, s1, s2 are our basic variables. Their coefficients in the objective function are 12, 16, 0, and 0. This is the objective function that we are considering, 12, 16, 0, and 0. Now, what we would be doing, we would be simply mentioning the first and the second constraint. So the first constraint, what are the coefficients of each of these basic variables in the first constraints? It's 10, 20. So let me write over here 10 corresponding to x1, 20 corresponding to x2, then 1 corresponding to s1 and 0 corresponding to s2. For the second constraints, we are having 8, 8, 0, and 1. This is our second constraint. This is our second constraint. And this is our first constraint. Write the solutions over here. It's 120 and it's 80. Now, what is the slack variable or surplus variable that has been used in the first constraint? You need to, at a very first instance, you need to always write S1 and S2. Why? I will be going to explain it once I complete this entire table. So right over here in the first constraint, which is the slack variable that has been used, it's S1. In the second constraint, which is the slack variable that is used, is S2. Now, the coefficient of the basic variables in the current iteration. So S1 is having the coefficient 0 in the objective function and S2 is having the coefficient 0 in the objective function. So that is the reason we will be putting 0 and 0. Okay. Now coming back to the question that was being asked by Devans and so on, why we are considering only S1 and S2? So the reason is that over here we are going in the step-by-step formation. Like this type of approach we will be following. This is the maximum value. This is the maximum value. This is the zero value. We will be starting from zero and we will be reaching to the maximum value, such that we would be taking this type of steps. This type of steps we'll be taking. How? So initially, what I will be doing, I will consider that, okay, my slack variables are only the variables which will be contributing towards my objective value. My slack variables, what is my assumption at this point of time? I don't know how many quantity I will be requiring. I am actually required to find x1 and x2 number of units. I am required to find the number of units for x1 and x2. Now I don't know how much quantity x1 and x2 will have. How much quantity x1 will have, how much quantity x2 will have, we don't know. So we just say that, okay, x1 and x2, it's just our assumption in the very first step that x1 and x2 are not at all contributing. This is our assumption. Start with some assumption that x1 and x2 are not contributing in our objective value. So we have started with S1 and S2. Because if I would be writing over here x1 and x2, then that means that two variables will be contributing in our objective function. But we don't know whether they would be contributing or not, whether both the functions will be contributing or not. How much amount they would be contributing, we don't know. So for that, we would be saying that, okay, let's start with the slack variable, that is the residual variables. The slack variables are nothing but the residual variables. They don't have any importance in our calculation. So we are starting that, okay, let's start with the slack variable, the initial point, and we are writing over here the coefficients. So that is what our assumption is, that we want to find x1 and x2, and then we would be starting with s1, s2, the slack variables, and then we would be removing the slack variables and introducing our basic variables. We would be removing the slack variables and introducing the basic variables as and when we approach to our solutions. So we would be looking into how we can introduce the basic variable and remove the slack variable in the later or in the next step. So this is the reason we have considered the slack variables, because we don't know in how much quantity x1 and x2 will be contributing. Okay, Viraj is to ask, I am not getting why we are adding 0 in S1, S2, it's equal to 0 then. Okay, so over here, are you asking Viraj, why we are adding over here 0?
No, no, sir. In the equation where you are converting it to
Okay, in this objective function.
yes, yes.
Okay, fine. So what the theory of the mathematical modeling says, that whatever variables are there in the objective function, let me write over here, whatever variables are there in objective function may or may not be in constraint. So that means whatever variables you are considering in the objective function does, doesn't mean that all the variables will have some constraints. There are the certain variables, there can be certain variables which are constraint free, that are free to move anywhere. You are not required to constrain all the variables. But contrary to this, whatever variables are there in constraint need to be there in objective function. So this is the rule of mathematical model. Why? Because you are saying that, okay, I am imposing this constraint. I am imposing this constraint over this particular variable. But without the usage of that particular variable in the objective function, how can you impose the constraint? For example, just let me give this particular example. On a particular, let's say, very congested street in the market or in the market street, suppose, for example, vegetable market street, there are one of the rule comes that the vehicle without the number plate will be fined. The vehicle without the number plate will be fined. That means you are imposing the constraint. You are imposing the constraint that the vehicle without the number plate will be fined. But at the same time, there is no vehicle that will be allowed to enter in that particular street. Or it is been banned to enter any vehicle in that particular street. Then that means your objective is nothing but to prevent the vehicle from entering the street, and still you are imposing the constraint that if any vehicle passes from the street, then you will be checking the number plate. But after all, you have even banned the vehicle movement in that particular street. Then what is the purpose of imposing the constraint of finding that? So it is the same thing that we are including this particular variable S1. We are including this particular variable S1. That means constraint is there. S1 is the constraint variable, but without the utility of the constraint variable in the objective function, it doesn't mean anything. So that is the reason we are including S1. But in order to prevent the changes in the objective function, we are also including 0. No doubt, the value is going to be 0 only. But since it is appearing in the constraint, we need to include it in the objective function. Okay. So the next step is nothing but, after having formulated this one, is to find Zj. Now, what is this Zj? That is, Zj is the objective function or objective value at a present iteration. The objective value at the present iteration. So for that, what you will be doing, 0 multiplied by 10. This is nothing but the number of units multiplied by the objective value. So 0 multiplied by 10 plus 0 multiplied by 8 plus 0 multiplied by 8. So what I will be writing over here, I will be simply writing 0 multiplied by 10 plus 0 multiplied by 8 for this iteration. Now for the next step, I will be writing 0 multiplied by 20 plus 0 multiplied by 8, again this one. I am simply multiplying these values and adding them. Same thing, 0 multiplied by 1 plus 0 multiplied by 0, so it's 0. 0 multiplied by 0 plus 0 multiplied by 1, it's 0. 0 multiplied by 120 plus 0 multiplied by 80, it's 0. So if I can just write it again, it will be nothing but all the values will be 0. All the values will be 0. Why? Because we are considering 0 units of S1 and 0 units of S2. We are considering 0 units of S1 and 0 units of S2. Now, if you are not considering any unit, then definitely your objective function will be having 0 only. Your objective function will always going to have 0 only because you are not considering any unit. And this is the same thing which I will be answering to the question of Viraj, that is it always going to be 0 in the slack variable? Yes. For every first step, remember this thing, for every first step, whenever you will be creating the simplex table, you will be getting answer 0 only. For the every first step, you will be getting answer 0 only. For each of the questions that you will be doing in every first step, you will be getting answer 0 only. Why? Because you are not having any of the slack variables that are included in the objective function, so you are including it. And you are giving the coefficient as 0. And you are multiplying 0 with all the values, so it is always going to be 0 only. So that is the reason you are always going to get 0 in the very first iteration. There can be multiple iterations. We are going to do multiple iterations in this question also. So this is the first iteration only where we are just discussing. So let me just write over here, Zj is nothing but 0, 0, 0, 0, 0. Next step is to find Cj minus Zj. Cj minus Zj. I will be explaining the importance of each of these variables. What is the importance of this thing? Okay, Cj minus Zj. So Cj is 12, Zj is 0, so 12 minus 0 is 12. Cj is 16, Zj is 0, so it will be 16. 0 minus 0, it will be 0. 0 minus 0, it will be 0. And over here, we would be just keeping it to be 0. So what does this mean? What does this mean? This particular step Zj will be telling that for each of the quantities that will be contributing, what will be the objective output value? So that will be nothing but it is denoted as 0. Over here, it is nothing but 0. Now, Cj minus Zj gives you the information about the rate of change in objective functional value. That means you are saying that, okay, with this particular solution where I am taking 0 units of S1 and 0 units of S2, I am getting my solution value as 0. Now, Cj minus Zj says that, okay, you are still having the chance to maximize your profit. You are still having the chance to maximize your profit. Why? Because there comes the condition of optimality. Now, this is very important condition, optimality. The condition of optimality says that for any of the maximization problem, which you are dealing with, all Cj minus Zj should be less or equal to 0. And for the condition of minimization, all Cj minus Zj should be greater or equal to 0. Now, what does this mean? Why it is called as the optimality? This says that there is the chance, over here you are having all the values greater or equal to 0. That means there is a chance of increasing or maximizing your profit. There is a chance of increasing or maximizing your profit. Now, for example, if I would be having over here minus 12 and minus 16, then that means that by further iterations, you will be reducing your profit. Why? Because the sign is negative. You will be reducing your profit, and that we don't know, that we don't want, because our case is maximization. Suppose we have got 120 as the profit, and if I still continue to have the iteration, then there is a chance that from 120 I may come down to 80. Instead of going high, I may come down to lower profit. So this is the important condition of optimality which you should be remembering and you should be highlighting in your notebook. That optimality is nothing but your end condition. End condition. Till what time you should be continuing with this process? Till the time you receive all the Cj minus Zz to be less or equal to 0. all the Cj minus Zj. I am writing all, not a particular one. So let's continue with this thing. It will be 12 and 16. So it is the indication that on further continuation, you may have higher profit values. So now your next step is to find, I'm writing over here, it was step 2. So step 3, I'm writing find key column, key row, and key element. This is your next step, to find key row, key column, and key element. Now, how can I find all these things? So for that, we are having certain other rules. Key column is nothing but highest value of Cj minus Zj. Now over here, I have told that this says that whatever value, if you are getting to be positive, then that means there is a chance of increasing your profit values. Now, compared to 12 and 16, it is said that the rate of change of the profit is more for X2. The rate of change of the profit is more for X2 compared to X1. Why? Because X2 is having higher value than X1. Rate of change of profit is more in X2 compared to X1. So what you would be doing, you would be considering the key column is the column which is having the highest value of Cj minus Zj. So over here, I am having this column corresponding to this X2 is having the highest Cj minus Zj. So I will be just marking that column. This is my column that is having the highest Cj minus Zj. Key column. So this column is called as the key column. So let me write over here, key column is nothing but the column corresponding to X2. You will be finding that why we are doing this so much of things, but this is the approach that we need to follow. For the simplex method, we need to follow this approach. The another reason is that the limitations of the graph method. There are also the limitations of the Gaussian methods, the Gauss-Jordan methods, Gauss elimination methods that you would have learned. So in order to meet with those type of the limitations, we need to follow this calculation. Now, once we are having this particular key column, you find the ratio. Next step is to find the ratio. Ratio is nothing but solution divided by key column elements. Solution divided by key column elements. So what you will be doing, solution is 120 divided by key column element. That is nothing but this is our key column. So what is the element in that particular key column is 20. So it will be 6. Ratio will be 6. Same 80. Solution divided by key column element. It's 8. So ratio will be 10. Now don't consider for this thing because our main portions are this two only. These are our decisional portion. This is our iterational portion. The top portion is our iterational portion. And the bottom one is our decisional portion, where using which we take the decisions, what to do. So for the computation of the ratio, you need to have only the iteration. You don't need to do anything. You don't need to decide anything. So that is the reason you don't do anything in the bottom part. Okay. So now, next step. Once you find the ratio, you need to find the key row. You need to find the key row. What will be the key row? It will be the lowest value of ratio. Lowest value of ratio. Now, what will be the interpretation of this key column and key row? I will be just saying once I complete this particular thing. Key row. So that is nothing but the lowest value of lowest value of the ratio. So let me just highlight this particular key row, which is corresponding to this variable S1. This is our key row. Let me write over here S1. And key element is nothing but key row intersection key column. So in our case, it's 20. This particular one, this particular element is our key element. 20. Okay. Now focus everybody over here. Now I'm going to tell what do we mean by key column and key row. So it means I already told what do we actually interpret by this particular field, that is Cj minus Zj. That is nothing but the rate of change in the profit. Rate of change in the profit. And we found that, okay, X2 is having the higher rate of the change. So that means X2 we have marked X2. That is, we are having higher change in the profit. We are having the higher change in the profit corresponding to X2. So that means our X2 will be giving us higher profit. So that means X2 is giving higher profit. Contrary to this thing, if we are considering X2 to be giving higher profit, then the ratio of the profit, that is the rate of the getting profit over here, the rate of getting profit having considered X2 will be less, because we are having the ratio to be less than this one. So that means if we are going to consider X2, then the ratio of the profit that we'll be getting will become less by considering this S1. So S1 is having lower ratio. If X2 is considered, so what we are going to do, we are having the wildcard entry of X2 and we are having the elimination of S1. Why? Because X1 is X2, this particular variable X2 is going to give us higher profit. And if we are going to consider X2, then the ratio of getting the profit will reduce because of S1. So that is the reason we are entering this X2 in our next iteration, and S1 is our eliminated variable. So that means we are going to include X2 and remove S1. So let me write over here. I will be asking you all if you are having any doubt after 1 minute. So let me write over here. Entering variable is X2 and leaving variable is S1. So this is nothing but whatever variable corresponding to the key column will be entering, and whatever variable that is corresponding to key row will be leaving. Construct the simplex table again. Construct the simplex table again in the same manner. Construct the simplex table again in the same manner. So we will be writing CBI, CJ, basic variables. Then the basic variables are X1, X2, S1, S2, over here solution, over here ratio. Same table. Now what we have done, we are leaving X1 and we are entering X2. So in place of S1, write X2. That means X2 has entered in our calculation. Now X2 has entered in our calculation and S2 remains the same. S2 remains the same. What is the coefficient of x2? So first of all, write over here the coefficients is 12, 16, 0 and 0 in the objective function. So write the coefficient of x2, it's 16 and s2 is 0. So what we have done, we have removed s1 and we have entered x2 in our calculation. So that means x2 will be entered in this table. x2 will be entered in this table. So we have found out that, okay, S1 is not contributing much in our profit. Why? Because it is having the very less ratio. S1 is not contributing much in our profit. So we have decided that, okay, let's remove S1. But we have found out that, okay, in place of S1, X2 is the variable which is contributing much in the profit. So we have entered X2. So you can see we have replaced S1 and we have entered X2. And corresponding to X2, we have written the coefficient that is there for X2. Okay. So till this point of time, anybody having any doubt? Anybody having any doubt? If you are having any doubt, then please ask me. What is the main intention over here? We are starting with the zero variable and we are finding that, okay, which variable is having higher importance, include that first, and which variable is not having any importance or very less importance, remove that variable. So like this, we are just trying to match with the variables in terms of their contributing abilities. In terms of their contributing abilities. Over here, we found out that S1 is contributing very less. So that is the reason we have to remove it. And X2 is contributing very high. So we need to edit. Okay. Next step. I have received around 6 responses that you are not having any doubt. So I am assuming that remaining people, since they have not responded, might not have the doubt. I don't know whether you all have missed the train or you are with me. I don't know. I probably hope that you all will be with me. Don't lose hope. It's very simple. For the first or the second case, you may have some difficulty, but once we have the ample amount of the practice, it will be very simple. Okay, last formula in this particular question. Last formula that we will be considering in this particular question. Okay, so I've got one question that explain how CBI becomes 16 and 0. Right. So over here, what is the CBI? CBI is nothing but the coefficient of the basic variable in the current iteration. So what does this mean? CBI, coefficient of the basic variable in current iteration. So in current iteration, what are the basic variables? It's x2 and s2. So what is the coefficient of x2 in our objective function? The coefficient of x2 in our objective function is 16. So we will be writing over here 16. And what is the coefficient of s2 in our objective function? It's 0. So that is the reason we have written 0. Rather than to move to the objective function, you can directly look over here. That was the reason we have mentioned over here the coefficients. They are the coefficients in the objective function. For x1 we are having 12, for x2 we are having 16, s1 is 0, s2 is 0. Okay, last formula that you should be writing, and then I guess our lecture will get finished. So it won't be possible for me to implement that formula, but we will be continuing with this thing in the next lecture also, because simplex methods are very difficult to get finished in one lecture. Okay, so These are the two cases that you should be considering. Variables. Now specifically I'm writing this thing for this part, for the part that I have just drawn. For this part, how to fill the values. We won't be filling up the values directly because at that instance, in a very initial phase, we have considered that our S1, S2 were contributing, but now we are considering X2 is contributing in place of S1. So we will be having the change in the values. So what will be the change? So variables, or let me write over here for the entering variable, for the entering variable, that is nothing but, okay. In this case, it's X2. In this case, it's X2. Divide by key element. Divide by key element. And for other row, over here we are having two rows. One row is nothing but represented by this entering variable, that is X2, and the other row, that is S2. You need to write the formula is your new value will be equal to old value minus corresponding key row multiply by corresponding key column divide by key element. That's it. This is the formula that you need to implement. Let's quickly, within 1 minute, fill up this table. Within 1 minute, we can fill up this table, I guess. Let's do that so that we can at least have this table to be completed. So over here, now quickly move to the table that we have drawn in our previous iteration. So this is the table that we have drawn. Over here we are having 10, 20, 1 and 0. We are having 10, 20, 1 and 0 in this first row. In this first row. And this first row is being replaced by this entering variable, that is X2. So if this particular row, what we need to do, we need to divide by 20, that is divide by key element. The key element is 20, so divide by 20. So divide all the values by 20. Divide all the values by 20. So 10 by 20, it's 1 by 2. 20 by 20, it's 1. 1 by 20 remains the same. And H2 is 0 by 20, it's 0. So this is what we have found out for the entering variable. Okay, I guess it will be taking time to calculate these things. I don't want to just hurry up in this first example. So I'll be continuing from the construction of this second table in our next lecture. So I will be requesting that it will be a gap of 3 days for our next lecture to come. It will be on, I guess, it will be on Monday. Till that time, there are the chances that you might have forgotten this thing. So I'll be uploading the videos by today itself, and I'll be requesting everyone to please come after watching the videos in our next lecture. The next lecture will be on Monday, and there are the chance that you might have forgotten this entire process. So please watch the video and then come, because I am not going to explain from the very scratch. Then again, it will be just holding at this step number 3. It won't be continued. So I'll be continuing from step number 3, but for that you need to come after watching the video. Fine. So I'll be continuing with this step in the next lecture. Everybody can write your roll number and name in the chat box, and you can leave for the next lecture. If you are having any doubt till this point of time, then you can ask me. Till this construction of the table, then you can ask me. Yes, I will be uploading the recordings by today only. All the recordings that I have not uploaded, I guess the previous lectures and this lecture.